Hello friends, welcome to Automation Community. In the previous video, we have discussed about NOR gate. We got to know how to implement NOR gate. Today, in this video, we will discuss about NAND gate. We will get to know how to draw ladder logic for NAND gate. So let's start. NAND gate is a combination of AND and NOT gates. As you can see in the table, when both the inputs are in false state, the output is true. And when one of the input is in true state, the output is also true. And when the inputs are in true state, the output is false. So in a NAND gate, the output is true when none of the inputs is in true state or one of the input is in true state. When all the inputs are in true state, the output is in false state. So now let's move to the EcoStruxure Machine Expert. We will draw ladder logic for NAND gate. We will open EcoStruxure Machine Expert. Firstly, we will keep the read protection as inactive and write protection as inactive as well, and then apply. Now we will go to the configuration tab where we will configure a logic controller. I will use TM221C24R. I will click on it and drag it to here. Do you want to replace? Click on yes. Then I will go to serial line and set protocol as TMS2GDB and then click on apply. Now I will go to the programming tab. So here we can draw ladder logic for NAND gate. I will click on full screen mode and I will zoom into it. As we are drawing ladder logic for NAND gate, I will name the rung as NAND gate. So to implement NAND gate, I will be using normally closed contacts or negated contacts. I will click on it and then click here. I will take another negated contact. I will click on it and then click here. So now I will insert a coil. I will click on coil and then click here. So we need to connect this contact to the coil. I will draw a line like this. So this contact is also connected to the coil. So we need to assign addresses to the contacts as well as the coil. I will click on address and then I 0.0 and I 0.1. I will also add symbol. I will click on it and type switch 1. Click on yes. Then I will also add symbol to this contact as well. I will click on it and type switch 2. Then I will click on yes. So the symbols are added to both the contacts. Now I will assign address to the coil as Q 0.0 and symbol as buzzer. I will click on yes. So the ladder logic for NAND gate is ready. I will exit full screen mode. Then I will compile it. And then we will go to commissioning. I will launch simulator. And then I will start controller. I will click on OK. As you can see, when both the inputs are in false state, the output is in true state. and when I activate switch 1, the current still flows through switch 2 and the buzzer is in true state. And when I activate switch 2, the current still flows through switch 1 and the buzzer is in true state. Now, if I activate both the switches, the current will not flow through either of the switches. So, the buzzer will be in false state. And when I deactivate both the switches, the current flows through both the switches and the buzzer is in true state. Now, we will go to commissioning. I will stop simulator. We'll go to programming, and here we can add another negated contact. I will click on it and then click here. We can also add another coil. I will click on coil and click here. So we need to connect these to the network. I will click on it and draw a line like this. So now we need to assign address as I 0.2, and I will also add symbol as switch 3. I will click on yes, and then I will also assign address to the coil as Q 0.1, and I will add symbol as motor. Click on yes. So now switch 1, switch 2 and switch 3 are the inputs and buzzer and motor are outputs. So when all the switches are in false state, the outputs will be in true state. When switch 1 will be in false state, then still outputs will be in true state. When switch 1 and switch 2 are in false state and switch 3 is in true state, then also outputs will be in true state. So for outputs to be in true state, one of the inputs should be in false state. At least one of the inputs should be in false states. And if all the switches are in true state, the current will not flow through it and the outputs will be in false state. Now we will compile program. Then we will go to commissioning and launch simulator. Now we will start controller. To do so, click OK. So here, as you can see, all the inputs are in false state. The outputs are in true state. If I will modify switch 1 as true, the two inputs are in still false state and the outputs are in true state. And if I modify switch 2 as true, the outputs are still in true state. And if I modify switch 3 as true, as you can see, all the inputs are in true state, which results in the outputs are in false state. It was all about NAND gate. Thank you for watching.